Today we're going to take a look at a very interesting tool called MLJAR Studio. You can think of it to be a little bit like a combination of coding agents and JupyterLab. In fact, it is exactly that. It is an AI data lab built on top of JupyterLab, and it's completely free. So we can work with interactive Python notebooks, and at the same time we can also chat with an AI agent and do agentic engineering. But it goes far beyond that. We can also connect various data sources like CSV files, databases, or Databricks. We can use AutoML to let MLJAR automatically find strong models and pipelines for our data. If that's not enough, we can also use AutoLab, which is an AI agent-driven experimentation layer. So the idea is we define the ML task, metric, constraints, etc., and it goes off into multiple trials and runs autonomous ML experiments, which are all saved as individual notebooks. We can publish our notebooks as standalone web applications using Mercury. And for all of this, we can either use the free built-in AI models or our API keys, for example, for OpenAI, or our self-hosted Ollama models. So what we're going to do in this video today is we're going to explore this tool and see what it's capable of. I think that this is going to be particularly interesting for data scientists and machine learning engineers. So if you like this video, let me know by hitting the like button and subscribing. And now let us get right into it. Alright, so we're going to take a look at MLJAR Studio in this video today. This is the website mljar.com, and as I said, this is basically a combination of JupyterLab and coding agents. It's like having JupyterLab, but with a ton of AI features that are quite useful. So you can say that this is kind of the Claude Code Codex, Open Code Pi, whatever you want to call it, for Jupyter notebooks, because all the terminal coding agents don't work very well when it comes to Jupyter notebooks and interactive Python notebooks. This is the environment you want to go with. Now, for the sake of transparency, I need to mention that MLJAR is sponsoring this video today, so you'll find a link to them in the description down below. Nevertheless, two things. I'm going to give you my honest opinion, and the other thing is it's free. There is a pricing tab here. They do have a free plan. You don't have to buy anything in order to use all the core features and also use some prompts. If you want to use their API for prompting, if you want to use their models for prompting, and if you want to publish more conversations and apps, we're going to talk about this here in this video, you can upgrade to one of the paid plans. But for everything we do in this video today, we don't need to pay any money. So you can explore this tool for free. And what you need to do to get started is you need to get it onto your system. So you can go to Download Studio and you will find the releases for the various platforms. We have Mac, Windows, and Linux. Now, I'm on Arch Linux. They don't have an official Arch package. They do have one for Debian-based distributions, which means also for Ubuntu and Pop! OS and so on. And they have the Fedora-based distributions, so Fedora, CentOS, Red Hat, and so on. If you want to run this as an Arch package, you can just ask a coding agent to take the .deb package and turn it into a ZST file, so install it with Pacman. That's not a problem. This is exactly what I did. So for those of you who are interested, I have here a package build file, which essentially turns this Debian package into an Arch Linux application, to a package for Arch Linux. So that's not a problem. You can run the tool also on Arch Linux. You just need to do some tinkering, but that's usually the case when you're running Arch. So once you have the tool installed, you can run it, MLJAR Studio, and you can open a directory of your choice. In my case here, I'm going to go with my tutorial directory. So I click here on Open Directory. This opens the file dialog, and I click on Tutorial. That's it. Choose, and then I'm basically in a JupyterLab environment in this directory. So this is literally what you know from JupyterLab, but we have a lot more than JupyterLab offers by default. So first of all, what I can do is I can right click and create a new notebook like usual. So if you know how these interactive Python notebooks work, you also know how this works. For those of you who don't know what interactive Python notebooks are, the idea is quite simple. You run individual cells. So I can say a equals 10 here. I can use a down here. I can say a plus equals 10 here, and I can run a up here again. So I can run individual cells of code in the same kernel. All of them belong together, but I don't have to run the full script from top to bottom. This is the default thing you want to go with if you're doing dataset exploration, if you're doing data science, data visualization, data analysis. Notebooks are usually what you use. You don't use Python scripts. So with MLJAR, however, we don't just have notebooks. We have an AI system. So I'm going to add a dataset here, which is the California CSV dataset. Feel free to use whatever you want. And for example, I can just say import pandas as PD, ordinary Python stuff. Data frame is equal to pandas read CSV, and then I can provide California.csv. Let me go full screen here. I can just run this, and I can also take a look at it. That's it. Now, let's say I want to ask a coding agent to do some analysis, to visualize the features, the distributions of the features, to also maybe plot a correlation heat map. And I want to do that here without copy pasting from different chatbots. What I can do is I can click on AI Data Analyst, and it's going to open this notebook in conversation mode. Now, I can do that in two ways. I can do it in this way, where I literally have this chat interface that is connected to the notebook, or I can do it with the sidebar. So I can chat while working in the notebook, and then I can just take the cells from here and apply them to here. We're going to take a look at both. Let's start here. I'm going to say plot the histograms for all the variables we have here. So this now is the chat interface, but it's still connected to the notebook. So whenever it does something here, it's also going to be applied to the notebook. It's just a different view on the notebook. So you can see it ran some Python code. I see the plots here, and in the notebook, I also see the visualization. So this is actually part of the notebook now. It's not just part of my chat. So you can see here, I have my data frame, everything I did before. And then here it added some markdown text and some code and also the visualization. This is one way to do it. Another way is, and we can actually look at this right now, I can open the sidebar here and give instructions. Now it says here I reached my prompt limit. If that's actually true, if it now rejects my prompt, I'm going to show you already the next thing I wanted to show you, which is you can connect your own models. So right now I'm using the MLJAR AI API. So I'm using their models, the 50 prompts I have in the free plan. I can also connect my own Ollama models, which I'm going to do here if it rejects my prompt. But let's say here, plot a correlation heat map for all features. Yeah, so you can see it says here you reached prompts limit, so please contact us for more. If we want, we can upgrade now. Otherwise, you can go up here to the MLJAR AI button. This will take you to the AI provider settings, and here you can choose another provider. You can go with OpenAI if you want to use your API key or subscription, or you can go to Ollama if you have a self-hosted model. So in my case, what I have is I have a Dell Pro Max with GB10. So this is a Dell and DGX Spark, so NVIDIA DGX Spark-like device where I run my models. I can choose Ollama here and connect to this device. It's tunneled using NVIDIA Sync. So right now I have NVIDIA Sync running here, which is connecting to my GB10. All not really important to you. What you need to do is you need to connect to your Ollama instance, whether that's on your PC, on your laptop, in the cloud. Just provide the correct base URL. Choose the model that you want to be using. In my case here, I want to go with GPT open source 120 billion parameters. This is what I'm going to use here. Test connection to see if it works. Save the provider. And now we can go back into the chat and see if I can continue. So I'm going to copy this and I'm going to paste it here again and send. And there you go. It actually starts producing this code cell. If I want to now take it from here into my notebook, I can just press this replace and run button. So I can just click here and it's going to put everything down here. Actually, let me try again. I think this was now pasted as markdown. There you go. So I can just press the button and it plots this correlation heat map. This is now with my own locally hosted model. So this is super convenient. And this is the basic idea. So you can have your notebook, you can work in this notebook manually, you can open it in chat mode where you can just interact with the model and it's automatically going to adjust things in your notebook, or you can be primarily working in the notebook and open the chat interface as a secondary co-pilot here and ask it questions and let it produce code cells, which you can then just insert below, insert above, or you can also replace and run. Also, a nice feature is if something goes wrong, whether that's your fault or the agent's fault, the agent can help you fix it automatically. So let's say I do something stupid now. I say data frame 2 is equal to PD read CSV, and then I say some file that does not exist, like California. So I just use the wrong vowel here, .csv. This is going to give me an exception. So it's going to say file not found error, and automatically it's going to give me a fix with AI button. And if I'm not doing this manually, it will also try to fix it automatically. So I can just say fix with AI, and automatically the agent is going to try to fix this cell. There you go, processing. And it's going to realize, okay, there's probably a typo. It's not California, it's California. So you can apply the fix and run again. So I can just press the button, replace and run, and it's going to remove my cell and it's going to insert the new code from this agent. Now, MLJAR also has a feature called AutoML, so automated machine learning. The idea is I have a data set. I want stuff to be done. I want to predict, for example, here the median house value, but I don't want to do the work myself. I want MLJAR to find a strong model and a strong pipeline for me automatically. I can do that with AutoML, and I can do that in two ways. One way is I can just go to one of the templates here. So on the start page, get started page here, I can go to machine learning and use one of the AutoML notebook templates here if I want to, or I can just start writing manually. So I can say use AutoML on California CSV, and then maybe to predict median house value as good as possible. Send. You can see that this opens up a new notebook. So this actually opens untitled IPYNB. It renames it to California AutoML IPYNB. And then it's going to use AutoML. There's a package from MLJAR that does that, a supervised learning package. So you can see if you uncollapse this code cell here from supervised.automl, import AutoML, and it's going to automatically find models that are useful for this specific use case. And it says here AutoML will use algorithms, decision tree, random forest, extra trees, light GBM, XGBoost, cat boost, neural network, and nearest neighbors, and it's going to select what works best. And you can see that it basically logs here what it's doing. It tells you what it's going to try. It tells you also that it's going to use 5-fold cross-validation shuffle. It also tells you how long it takes to train the individual models, and in the end it will give us a summary, a report. So it seems like it's done. Let's ask it, so what are the results, question mark. And there you go. Now it displayed the results again and opened this AutoML report view here, which shows me the models. So the model name, it shows me the model type, the metric type R², and it shows me the value and the train time. And then I can find the best model here, which is the ensemble stacked, an ensemble model. It has 0.862 for the R², and it took 0.71, I think that's seconds to train this. And also it visualizes everything. It shows me here that, what's the best? I want to have the highest score possible. The ensemble is this, so that is the highest score here. And it shows me also some correlations of the models, but it gives me a full report. It tries different models on the data set, evaluates them, and then gives me the best solution, which in this case is also a very fast solution. Now, this is for AutoML. There is even a more comprehensive version of that called JupyterLab, and you can find it if you open a new tab here, and if you go to machine learning, you have here a template optimize ML pipeline with JupyterLab. The idea is that this runs experiments autonomously. The agent runs experiments in multiple notebooks. So it looks at the results of the first notebook, and in the next iteration, in the next trial, it does something different. And it does that in a very comprehensive and complicated manner. So we can open this and we will see that there's a whole graphical user interface that asks us what we actually want to be doing. So we as the human still need to be the architect, but the agent is going to do all of the work. So I can say, for example, I want all my results to be in experiments and then run -001. I think this is the default that they provide in the comment here. This means that it's going to save the results there. Then I can say, what kind of data are we even talking about? And I can say the California CSV dataset in this directory. And I can say the target variable is median house value. Now on their website, they do actually have a guide for this. They show you how to use this tool, and you can see their kinds of inputs. So they also provide a directory. They say load CSV from whatever. They define a metric, and then they say something like use 5-fold cross-validation. I'm not sure if you can read this right now. Use 5-fold cross-validation, compute RMSE on each fold, report mean RMSE. So you can really define the whole experiment logic here. I want to keep it very, very simple for demonstrational purposes. So I'm really going to just say RMSE, and I'm going to say compute the RMSE in the most minimal way possible, just because I don't want it to take forever and write a ton of code. I want to show you the simple principle, but of course you can provide more detailed instructions here. So I'm explicitly going to tell it to keep it minimal and concise. So compute the RMSE in the most minimal way possible, concise and simple, test different models. And then I'm going to say I want to have 3 notebooks, and per notebook, I want to have quick smoke 5 minutes. But as you can see, I can say 10 notebooks, and I want to have deep tuning, so 120 minutes, 2 hours per notebook, where it can play around with the data, try stuff. So this can also be let running for multiple hours if you really want this to explore a data set, play around with it, do hyperparameter tuning, compare different models, select features. All this can be done behind the scenes automatically with multiple notebooks. So I'll do just that. You can also say here missing packages can be installed automatically. I would recommend that. Continue to data profile. This is going to get the data, analyze it, and summarize the findings. This is important because that is what the agent is going to use to create the plan MD, which is the final instruction to the agent. So here you can see that this is the California data set with 20,640 rows, 10 columns, and so on. It doesn't have a target profile automatically out of the data. That's not a problem. We can say generate plan MD, and this is going to take this now with my input and generate the plan MD. And in case you're interested in that, you can see my model is currently being utilized here 95%. And we have 75 gigabytes of system memory that is being used for this. So this is still running on my own local model using Ollama. Here we have now the plan MD, and it summarizes what we want to do. The objective, the data source, the target column here as well, what kind of data we're working with, the scoring mechanisms. We want to minimize the RMSE, the root mean squared error. It also plans here how to do that with scikit-learn, the optimization strategy. And you can take a look at this, read this, say that sounds good, and then you can say save and run to actually execute the plan. So this opens this monitor view, which means that we have 0 out of 3 notebooks created. It's going to start creating the notebooks, and in the notebooks, it's going to do stuff. It's going to do the evaluations, the training, the scoring, and everything. And after that, it's going to evaluate it. It's going to take the RMSE, and it's going to start a second notebook. And then we're going to see a graph that shows the metric that we're interested in, the RMSE, how it develops from notebook to notebook. But instead of waiting for all this to finish, I'm going to show you the results of an experiment I ran earlier. So yesterday, actually, for preparing this video, same prompt, same data set, same idea. We just have 3 notebooks, RMSE for the California housing data set. And this is then what the final result looks like. So here we have the metric. We start with this RMSE with the first notebook. The second notebook achieved the lower one. You can see how it went down here. And then the third one also decreased the score a little bit, which is good in this case because we want to minimize it. And then we can see the best RMSE. All the notebooks here are listed. We can see the plan and the outcome. Let me zoom out a little bit. I can open the artifacts if I want to, which are some files here. But I can also just open the individual notebooks and see what they do exactly. Then we can see quite a bit of code. This was done with the MLJAR AI model, so it's more capable than the thing I'm running locally here, the GPT OSS 120 billion parameters. But then it gave me here the output. It started a third run. The third one gave a different output. And all of this was summarized in this interface. And in the end, I end up with the best results, which is the best RMSE. And then I can take a look into the artifacts and also get a summary of what happened. So back to my weak model here. Let's stop the experiment. I don't want to wait for this to finish. What else can we do here? We can also connect external data sources. So I can, let me close all these notebooks here. I can create a new notebook, or I can also start directly here with this chat interface. It says here already connect database. So I can just click on this. And what exactly you want to connect is up to you. You can go with Postgres if you have one. You can host one locally. You can have one in the cloud. You can connect Supabase, MySQL, Snowflake, Databricks, whatever you want. I'm going to connect Postgres, and I'm going to run this locally using Docker Compose. So I don't want to make this a Postgres tutorial, which means I'm going to just copy paste my setup here. I'm going to go to my tutorial directory, create a directory called PSQL stuff. I'm going to go into that. I'm going to create a Docker Compose YAML file. In here, I'm going to copy paste this service, very basic Postgres 16 database here with demo. This is the database and also the user and password. And then of course we need some data to play around with. So I'm going to create an init SQL file, and I'm just going to have some create table and insert statements. We have people owning stuff, so people owning items, and then some examples of that. Nothing too fancy. Then with all this setup, I'm going to say Docker Compose up to actually run this database on localhost port 5432, which is the default Postgres port. I'm going to say demo database, demo user, and demo password. I'm going to test the connection to see if this works. It works. Save the connection. And already it says here I can select the tables for AI context. So now I can say save selected tables, and I can say load the DB data and turn it into a pandas data frame. Now you can see here it uses SQL. It actually has this SQL query here with joins that load the data frame here. We have the table. I can also open this as an AI assisted notebook. So you can see we have here this select statement, and then I have the df-SQL or SQL1 data frame, which I can also go in here and say type df-SQL1, and you're going to see that this is a pandas data frame, so I can actually work with that. So of course, this is just a proof of concept, but you can do a lot of stuff with that. You can connect a database, you can load a CSV file, you can join the data, you can export the data, you can do a lot of stuff, but you can essentially easily connect stuff here to the AI by just providing the connection details. And by the way, also in case you didn't notice, you can set the reasoning level of the bot. In my case here, I only have default because this is my locally hosted model. But if I go and switch back to MLJAR, so if I say test connection, save provider, and I open maybe a new chat here, I can go to think and I can say think fast or think more. This will make the responses more sophisticated or just quicker. So finally, I want to show you how you can publish your notebooks as standalone applications, as web applications. This is super interesting. Now, on the one hand, you can take any notebook and just do that. You can just say publish and it will ask you to provide a Mercury page. I do already have one here. By default, you don't have one, so you have to create one. But essentially what you can do is you can use one of the templates as a demo example. So you can go to web app here, for example, and use the pricing calculator. So I can click on this, and then this opens up this pricing calculator as a notebook and also as an application here. And this is basically the code. It uses Mercury behind the scenes. You can design your UI here. So you have the plan, you have the different sliders here for taxes, discounts, and seats. Then you have also some Mercury elements that display the results. And this is the thing without the code. So this is the final application, which runs as a Jupyter Notebook. Now you can take this Jupyter Notebook application and publish it online. So you can click on publish. You can select a page. By default, it's going to not have a page. So you can say open Mercury. This is going to open it in the browser. So I can actually delete this page to recreate what you have by default. So if you run this for the first time, publish, it will say you don't have a Mercury page. I can click on create this page. Then here I can choose a title. So Neural 9 tutorial page, for example. I can say nntutorial.runmercury.com. I can leave the default settings, click on OK. Now I have this running. Now I can go back to my notebook, click on publish, choose this page. Next, I can choose this particular notebook here, add the files, and what's going to happen then is that this runs on this website. So I can click on this, and now I will have a web application that I can just click on here. So it has this Mercury page, notebooks, pricing calculator. I can click on this, and this will initialize the web application, which is the notebook. So you have a full URL to this tool. This is perfect for developing internal tools for your company, data analysis tools, dashboards, pricing calculators, standalone, simple web apps that are based on a notebook. And I can now just play around with this and it will interactively give me different results here. So all in all, this is a super interesting tool. As I said, it's basically a coding agent for Jupyter Notebooks. It's JupyterLab with AI features. Super, super interesting for data scientists and machine learning engineers. I recommend you check it out. The link is in the description down below. So that's it for this video today. I hope you enjoyed it and I hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. Also, don't forget to check out MLJAR, the sponsor of this video. The link is in the description down below. You support the channel by checking out the sponsors. Besides that, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video and bye.